All right, so again, NH3 is polar. This is polar because when you draw your X and Y axis, there isn't symmetry. We're missing an H. So you need symmetry on both the X and Y axis. So we have it on the Y, right? So we split it this way vertically. You technically have mirror images, right? One electron on each side. But when you do this way on the X here, it's not. There's no H here. There's 2 electrons here. There's no electrons here. They're in the bottom. So it's polar because it's not symmetrical. Also, electronegativity of N is 3, and each H is 2.2. So the nitrogen is pulling the electrons towards it. So in general, the way you would draw a dipole would be up. All the electrons are kind of getting pulled this way. And the reason for this is if you look at this structure right here, if I take this off, this is what NH3 looks like. You have your N, and then the 3 H's are kind of bent down a little bit. So the N pulls in this direction, and in this case it would be up. It depends on how I hold it. But it's going towards the black one here, which we could say is nitrogen. So there's our dipole. So this part of the molecule is partially negative, and then this side is partially positive. All the hydrogens are partially positive because they're getting their electrons pulled in that tug of war towards nitrogen. Over here, nobody wins, so it's nonpolar. There's no dipole moment. It's very symmetrical. All 4 Cl's are pulling equally, so that's very symmetrical. Nonpolar, we don't need any of this stuff. So on your lab, you're doing all of this. You're going to put it together with the kit here, models. You're going to draw dot structures. You're going to label electronegativity. You're going to label dipoles, partial negatives. For the nonpolar, you just do this. Draw a dot structure, make the structure, and then you're basically done. But you're going to have to explain why it's polar or nonpolar. So you would have to say it's asymmetrical, unequal sharing, however you want to word it. And this is equal sharing, symmetrical. Okay. CO2. I'm just going to give you the dot structure because it's going to help you in lab. CO2 looks like this. 2 what's called double bonds. There's 3 types of covalent bonds. A single, a double, and a triple. Hey.
We're good.
Oh, did I leave that in your room?
No, I got it in my
Oh,
mailbox.
okay, because I had one the other
Okay.
day. Thanks. So CO2 has 2 double bonds, and the reason for that is because of the full valence shell, the octet rule, which I'm running out of time here to try and explain, but I want to at least throw this on the board here and help you out in lab, because CO2 does not look like this. It's not bent like water. It's called a linear. It's straight molecule. Linear. So when you split this in half, either way, it has symmetry. So CO2 is very nonpolar. And again, I showed you with the sheet there. Oxygen has 3.4, I think? 3.4, carbon 2.6 electronegativity. So each oxygen is pulling and winning that tug of war, but since they're opposite each other, they cancel out. So there is no net pull, no net direction, no poles. So that's nonpolar. All right. I got a couple minutes. I'm going to use it here. So let me recap. Can you draw a dot structure? Can you figure out polarity based on symmetry? If it's symmetrical, it's nonpolar. Asymmetrical, polar. But then can you explain it? Right? Can you draw the dot or the dipoles with the partial charges? So there's different levels of understanding and different types of questions. Most questions on the regions, you just need to be able to say, is that polar or not polar? Not do a whole lot of other things. Okay, same thing with the polar. Just can you say it's polar or not polar? Okay, so last thing here. Let me make sure you got enough for your homework. Yeah, you do. Okay, so do that for Monday. Last thing here. single bond, double bond, and a triple bond. Let's just get one example of each, then we'll stop there. Alright, single bond would be something like H bonded to an H. A double bond would be something like O bonded to an O. And triple bond would be nitrogen triple bonded to a nitrogen. These two, O2 and N2, are the only two that you're going to see with the double or triple, except for CO2. So CO2 has the double bonds, meaning there's 2 lines between, and then 3 lines means triple. I obviously don't have enough time to get into the details. We'll pick up with this on Monday, but I just wanted to at least introduce these do exist, and we'll talk about that on Monday. So don't forget the worksheet, and that's it.
A lot of games now.
Mr. Decker?